Imagine you're labeling every word in a sentence, tagging which words are names, which are places, which are organizations. You could classify each word on its own, and plenty of systems do exactly that. But there's a catch. Labels aren't independent. An inside organization tag can never follow a begin person tag, because that sequence is simply not valid. A model that judges each word alone is blind to that rule. This is the problem a conditional random field, or CRF, was built to solve, and today we're breaking down how it works. So let's start with the core contrast because it explains everything that follows. Consider the naive approach first. You run a plain classifier over each word, one at a time, and pick whatever label scores highest for that word in isolation. It's fast and simple, but it throws away a huge signal. It never checks whether one label is even allowed to sit next to the label beside it, so it happily produces sequences that break the rules of the task. Now the CRF flips that. Rather than scoring words one by one, it scores the entire label sequence together as a single joint decision. It rewards labelings where each tag fits its word and every neighboring pair of tags makes sense. That way the impossible transitions get pushed down automatically, and the whole sequence stays coherent from start to finish. Now let's follow how a CRF actually turns a sentence into a score, step by step through the pipeline. Everything begins on the left. You feed in the sentence along with a candidate label sequence you want to evaluate, something like person, person, other, organization. The CRF's job is to say how good that particular assignment is for this exact sentence. At the center, the model computes two kinds of scores. First, word features tie each label to evidence in the text, like capitalization or a known prefix. Second, transition features score each adjacent pair of labels, rewarding legal handoffs and penalizing the ones that can't happen. Then comes the part that makes it a proper probability. The model normalizes across every possible labeling of the sentence, dividing this candidate's score by the total over all of them. That's what turns a raw number into a clean conditional probability of labels given the words. Finally, on the right, you decode. Rather than enumerate every labeling, the Viterbi algorithm walks the sequence efficiently and recovers the single highest scoring path. Out comes the best label for every word, chosen jointly rather than one at a time. So what makes a CRF worth reaching for? Three ideas really carry the whole method. Foremost, it labels the whole sequence jointly. Because it scores an entire tag sequence at once, it can enforce structure that per-word classifiers never see, keeping the output valid across the sentence. Beyond that, it's discriminative. Unlike a hidden Markov model, which describes how the data was generated in the first place, a CRF directly models the labels given the words. That freedom lets it pile on rich, overlapping features, capitalization, prefixes, neighboring words without ever worrying about whether they're independent. Third, it models label-to-label transitions explicitly. Those adjacent label scores are exactly why a CRF layer still gets bolted on top of neural networks today, giving a BiLSTM a principled way to enforce valid tag sequences and rule out the impossible ones. Alright, let's lock in the four things worth remembering. Conditional random fields, introduced by Lafferty and colleagues in 2001, predict a label for every element of a sequence while considering the whole sequence at once. Rather than classifying each word alone, a CRF scores an entire label sequence jointly, combining word features with transition scores between neighboring labels. Being discriminative, it directly models labels given the observations so it can freely use rich, overlapping features, and decoding the best sequence uses Viterbi. From tagging parts of speech to named entity recognition, and still today as a layer sitting on top of neural networks, CRFs turn up almost everywhere that sequences need labeling. For more machine learning ideas explained in plain language, come visit standarity.com.